be covering today in terms of our seismic time history analysis and what we really want to talk about. So we have some other topics that we've addressed this same subject, but I want to actually take a little bit of a different approach today. And instead of getting into all the mechanics in a STAAD.Pro model, which we will look at some STAAD.Pro models, but instead of getting into the mechanics of actually going through the time history, loading and all that, we want to look at why it's important to perform a seismic time history analysis for your project. We want to figure out how we can get the historical seismic time history event data. And then once we have that data, how do we process that data to go into your STAAD.Pro model? And so those are the three topics that we really want to cover today. We have recordings that cover in detail the steps that follow after you've processed the seismic history data and brought it into your STAAD model. So we don't want to repeat all of that. I think it's important to cover these three items today so that you really get a good sense of what you're doing and why you would want to do it. And so that should be beneficial for you. So what are some of the benefits that you're going to gain from this? The seismic time history analysis, by performing a seismic time history analysis in STAAD.Pro, you're going to gain an extra level of confidence in your structural analysis and design. So for most projects that we're considering seismic design, we're going to model a equivalent static force that considers the seismic loading on our structure. So we're converting a dynamic seismic load to a static force, and we're applying it to our structure. But by actually accelerating our structure and applying the dynamic loads, we'll get an extra level of confidence that what we're actually modeling and using for our loading for our static load case is conservative enough. And then we want to also be able to understand the bigger picture with a greater amount of insight and clarity. So I'll get more into that detail on what I mean by insight and clarity. And then we also want to keep up with the most modern standards and achieve optimal results. Sometimes, depending on the type of structure you have, or the size of the structure, or the geometry, your results will change whether you're performing a dynamic analysis versus a static analysis on your structure. And so in order to achieve the optimal results, you really need to look at both scenarios to see where, if you're being overly conservative, or maybe you're not conservative at all. Maybe your structure is at risk. So these are some things that you want to consider. Another benefit is in STAAD.Pro, we make it simple to perform a complex dynamic seismic analysis. So it's actually easy to do. So it's not so much more extra work than it would be in performing the standard static loading on your structure for seismic. Okay, so now that we've talked a little bit about that, let's cover why perform a seismic history analysis. And so, in my opinion, and from the research and experience that I have, there's three primary reasons why we want to perform a seismic time history analysis. And those are safety. So we want to make sure our structure is safe. And when I say safe, most of the time for seismic, we're evaluating whether our structure is going to fail or a portion of our structure will fail. So as long as we consider that structure of that portion of the structure does not fail, we consider it safe. But with seismic events, often the structure may not fail, but there could be damage to equipment. There could be damage to other elements of the structure that are not keeping it standing, but are important to the overall workings of the structure, and therefore safety becomes another level, not just in terms of collapse or failure, but how important is this structure to the overall infrastructure of the location where it's located? Is it a hospital? Is it a school? What happens after the seismic event? Do they have to close the school, close the hospital? So these are all important safety reasons why we would want to do a dynamic analysis and consider more than just the failure of members or the structure as a whole. Some other factors are structural sustainability. Again, if your structure is still standing after the seismic event, but it's in such a condition where it needs to be demolished because it's no longer viable, then you don't have that structural sustainability. And then the third reason would be your design requirements. Are you up to date with the most current design codes? Are your methods that you're using also up to date? And so the other reason we want to do it is because it's easy to do in STAAD.Pro. So why not just take a chance and do it as well? Okay, so now let's get into a more in-depth discussion on the safety, structural sustainability, and design requirements. Then I'll show you exactly how to go get the data that you need for the seismic time history loading, and then how to process that data into your STAAD model. Okay, so one thing we want to do for safety is once we've evaluated our seismic loading, we want to say, do we need to implement any different structural elements into our system that is going to help this structure perform better? So there's several different types of things that we can do. We can put in seismic bracing like you see here. We can also do provide damping, seismic dampers on our structure. And it's not just limited to building structures. Obviously here you see a bridge structure. So a variety of different structures that you can place these different structures on, or excuse me, different elements that provide you better stability and either stiffness or dampening effects on your structure. So here's an example of some dampeners that can be used to control some of these dynamic forces. And here's an example of a buckling restraint brace. So lots of different options that you can use when you're taking into account the dynamics effects on your structure and to help them perform better and make them safer. Here's another one, base isolators. So if you're not familiar with a base isolator, generally how it works is it works to reduce the acceleration and the displacement of the structure by isolating the base, so that when the acceleration of the ground takes place, it actually reduces the amount of displacement as well as acceleration. So you can see kind of how that's happening here by these diagrams. And there's another mechanism that can help control the type of loading, forces, and accelerations on your structure. So this is another one of a seismic controller device, which uses the pendulum action here that suppresses the motion by applying opposite forces in direction. So you can get all this information on the web, but these are real structures that are being built into, or real mechanisms that are being built into structures to provide additional stability to the structures during seismic events. So here's an actual picture of the real constructed pendulum inside of the building. Okay, now those are some good reasons for why we would want to to do our seismic analysis, and also how we would implement some control systems to account for those dynamic effects. Now, how do we obtain our structural data so that we can use it in our structural analysis? I'm going to go to a website here, and this website is on the USGS site. It can be accessed from the USGS site. So let me pull that up right now so you can take a look at it. And I'll show you what type of data that they have here so that you can access that directly. So I'll go back a couple pages here so that you can see. And this is it's a little bit hard to read, but if this is on, like I said, the USGS website. So the link here is earthquakes.usgs.gov/data. And if you go there, let's take a look where that will bring you, and I'll show you how to get. So from there, from that website, earthquakes.usgs.gov.data, you can go right here to the seismic wave forms. And this is where you're going to be able to pull up different data from around the globe related to the the historical time data that you need for these seismic events. So from there, I'm going to go here to this USGS National Strong Motion Program, okay? And then if you follow the links, you'll get to the Center of Engineering Strong Motion Data. So this is ultimately where you want to end up. So if you want to just go directly to this website here, the website is strongmotioncenter.org. That's strongmotioncenter.org. And once you get here, you can pull up all the data that you need. So you'll see that here, there's a button for data for latest earthquakes. You're going to click on that button, and it literally lists most recent earthquakes by date. So you can see these events are happening. Some of them are very small, but then you can choose this button here for the latest significant earthquakes, okay? And it's going to show you around the globe those earthquakes, when they occurred, and at what location. And from here, you can actually access those the data that you need. So let's say I choose one of these. Okay. This is for an earthquake that happened in 2017, April 24th. And this was in Chile. And then it's going to have the strong motion data. So from here, what you can do is you can choose to download this information. And once you download that file, so I'm going to show you how to download it. Just click on download. You can choose the type of data that you want, either processed or raw data. So I'm going to go with processed data here, but you can also choose raw data as well. And you have to put in your credentials, so you have to log in. And I've already registered, so I'm going to put my credentials in here. I'm showing you this live, even though I've already done this before. So you set up a login, and then it'll take you to this download page here, okay? And then you just choose to download the processed data. So you can save this wherever you want, okay? So I've already saved this file, and I'm gonna show you what I've done with it once I saved it, okay? So that's where you're gonna get your data from, okay? Now, once you've got that data, you're gonna use a converter that will allow you to convert that data into usable information, because it's literally the information that comes from the seismic event that's recorded by the seismic device, okay? So you need to convert that data, I just showed you how to access different events around the globe and pull that data in, and then you're going to convert it. So there's a converter that's called the Cosmos converter that is also, you can download from the same website there, and you can use that to convert to an Excel spreadsheet. And that's what I'm going to show you next, okay? So we downloaded that data, and then we're going to convert it from the existing format. So let me show you what the existing format is, and let's, I'll just do the list here. Okay, so the existing format that you would get once you download that data, this is actually for California. It's going to come in up after you convert it. Actually, it'll come in like this. Let me go to some unconverted data for you so you can see that. Okay, so here is the file, how you're going to get it, right? The file is going to be in a zip file. You're going to unzip it, and then you're going to see this format right here, okay? So this is the data that is basically unprocessed. Now, what I can do here is I can open up my converter program. So I actually have that in another folder. And let me go get that right now. So here, this is the converter program, and I should just copy this to the SIG file that I was working with. Let me go back. Okay. And, oh, sorry. I want to go to Insider Skills. There we go. So this is, I just copied the converter over here so I don't have to keep jumping back to that other folder. So in here, when you download that converter, it works just like this. So you can actually browse, choose browse, and then you're going to go to the location where you downloaded the files. And you, of course, you're going to unzip those files first. So I'm just going to browse now to the location where I saved the files to. And then I'll show you how it converts those. Okay. So here I'm going to go to my STAAD model, and here I'll go back to Chile. Now I've already done this for California, for Chile, and for Mexico. So and actually Japan and Venezuela. So you can download these different events from all around the globe, depending on where you have you're considering your structure to be designed, and if you want to see how your structure will respond from a seismic event in that area. And then you're going to go into the location where you downloaded, and you're going to choose to choose the file you want. Now, let me just not overwrite what I already have. So I don't want to do that. Give me a second here. So what I'm going to do is just, I do want to demonstrate it for you, but I don't want to overwrite what I've already have. So I'm going to just copy this folder one time. And I'll put it over here. Okay. All right. So this is this is where I'm going to access the file for. So I'm still browsing, and what I'm going to do, I'm going to go to this folder here, and this is going to be the input data. So you'll see that there's actually 3 files in here. One has an E, N, and Z. So that's east, north, and Z is the vertical direction, okay? So when I choose open there, it's going to open that file, and then I can choose the type of format that file is in, and I can choose the output. So I'm going to choose these formats, and then I'm going to choose export. Now, in this particular model, I need to choose a different one. So I think I need to choose this one. So you have to align the correct format. So here you see it says SMC, and this also says SMC. So you know what type of format input that you're starting with. So when I choose export, it says it's done. It's created that one. So it created that first file for me. Then I can go to the second one here. So open that one up. Again, export the third or the second one. And now I'm going to export the third. Okay. And then I'll have all the data I need. Okay, so I'm done with converting those files over. And what I can do now is in this folder here, you'll be able to look and see what's happened. So again, you'll see today's date and time. I just converted those. And when you go in here, this is what you end up with, okay? After converting all that data, you're going to get the time history information for the seismic event. Okay, so what you're actually interested in the most is your time versus your acceleration. Okay, so you can see that in this file, it's converted all this data over to time versus acceleration. And this is the data we actually want to bring into our STAAD model. So now we've chosen the location and event that we want. We have converted that data over into time versus acceleration. And now we can use that in our STAAD model. But there's a couple of things that we want to do before we bring it into our STAAD model. So one of the things we want to do is, instead of having our acceleration in centimeters per second squared, we want to have this acceleration in our gravitational unit. So the acceleration due to gravity. So we want to convert this over to the acceleration due to gravity. So the acceleration due to gravity is 9.81 meters per second squared, or 981 centimeters per second squared. So that means if we divide these values by 981, then we will get the acceleration in our gravitational force, which means we can use whatever units that we want in our STAAD model. We don't have to work in centimeters per second squared. So that's one thing we want to do, is convert over these values. And the other thing we want to do is, we actually don't need this starting at time 0 and going all the way to 160 seconds. We can look at right where the seismic event really starts, which is right here about 60 seconds. And then we can go to somewhere down here where it tapers off at about 105 seconds. So we can actually truncate this data so that we're not using the whole thing. So I've already done that, and I'm going to show you an easy way to do it. It's not hard at all. And once you set it up one time, it's very easy. So let's go to that file. So I'm still looking at I'm going to go to California right now so we can see that one first. So in California, I've done the same thing, where I downloaded the data and then I converted it, and now I've processed it. So in this model here, what you're looking at is that same information, but I took this historical event, and the first thing I'm going to do is figure out what is the direction of this of the acceleration. So the direction of the acceleration here is east. The reason I know it's in the east direction is because they give an azimuth value and an inclination value. So this is going to be azimuth 90 degrees and also inclination 90 degrees. So this is going to be facing east. Okay, so I have all that data for the east direction. Now, in the spreadsheet page right next to it, I copied and pasted the time versus the acceleration. So here, those exact values from the other page, I copied and pasted here. And you'll see that instead of starting at time 0, I'm starting at 10 seconds, okay? And then if I go all the way, scroll to the bottom here, I went for a total from 10 seconds to 65 seconds. Now, I have all that data in there. And then I want to convert the accelerations from centimeters per second squared to Gs. So that's what I did. So in order to do that, I divided by 981 there. So centimeters per second squared, which is the acceleration due to gravity. And then for the actual model, I want my time to start at 10 seconds. So here I just subtracted 10 from here to make it 0. So I'm starting at 0 seconds, and it's going to go all the way up to 55 seconds there. So that's the process I did. Very simple, nothing complicated about that. And now I can copy all of this data to be used in my STAAD model. Okay, so I'm just simply copying these two columns down. Okay. Okay, so I'll highlight those columns and hold Control C to copy those two columns, right? Copying all that data right there. So from 0 to 55 seconds, I'm copying that information. Now, where do I want to put that information? I want to put that information in a location where I can use it in my STAAD model. So I already have, I've already done this once, so I'm going to show it to you again. But I have these text files, and in STAAD.Pro, you can pull a text file in with your time history data directly into the model. So that's where I'm going to copy this text into. So let me go to this EQ data 2. And what you'll notice is in this file, I have the time in seconds, starting at time 0, and the acceleration in the second column. So I'm going to replace all of this data that's already in here. It's just two columns. And if it was a blank model or a blank file, I wouldn't need to replace it at all, but I already have some information in here. So it's fine. I'm just going to paste this in, and I'm going to copy over the time versus acceleration that's in this file, okay? And then I'll just save it as another name, and I'll show you how to use this in, so I'm hitting Control V to paste, and I'll show you how to use this in your STAAD model. Now, the details of setting up the time history load we've already covered in other courses, so we don't need to go over all of that in detail. But the most important thing I wanted you to take away from this particular special interest group is where you can go to get the data, and then how you process that data, and then how you get it into your model. So at this point, we've located the data that we want, we processed the data, and now we're creating a text file that we can use in our STAAD model. So we're going to pull this in. So why is this important? Well, it's important because I actually have the actual accelerations from a historical event and I want to see how that historical event is going to impact my structure that I'm designing, and make sure that I have designed for the dynamic effects of this event on my structure. Okay, so I just did that. I have that, I saved that file right there, and it's in the same folder as my STAAD model. So let's take a look at the STAAD model now, okay? So I'm gonna go to STAAD.Pro, and I'm gonna open up the STAAD model. So we were working with California and Chile. So let's, I think I just did California. And so I'm gonna open up the California model. So that is actually the span that I'm gonna use for all the different historical data. So I can, once I have my model set up, it's just a matter of using different historical data to compare the impact or the dynamic loading on that structure, and see how that actually impacts the structure in different ways, okay? So this model is completely set up. So if I go to loading over here, you'll see that I already have a time history definition. So let's take a quick look at this time history definition, and I'll show you how to change it. Okay, so here in this model, we actually are looking at the acceleration of the ground, and we're going to actually pull in that information from an external file. Okay. Now, if we wanted to type in all of those values, we could just type in all those values or copy paste those values in here. So instead of having all those values in the text file, we could just copy paste the time versus the acceleration. Notice the acceleration here is in feet per second squared. So if I was going to copy in the values here, I'd want to do it in feet per second squared. But if I pull from an external file, that is actually easier, because it's easier to switch all those values out, right? And then the third way to define a dynamic acceleration or force would be to use a harmonic function. And so this wouldn't be a historical event, but it could represent some harmonic acceleration on your structure. So we're going to use the third option here from an external file. Now, since I already have this set up using an external file, I can actually just go straight into the editor. And in the editor, I can scroll down to where I have my time history definition. Okay. And then all I need to do is change the name of this file. Now, this file does need to be in the same folder as your STAAD model. So the EQ data file that we just changed, that we just updated to, we called it EQ 2019B. I think I used a lowercase b. I'm gonna check that because the text does matter, I believe. And then so you can update that data, and as soon as you update the text there in your editor, it will update all that data for the model. So let me just go ahead and verify the name briefly here. Yes, so I did spell it correctly. And now we're gonna go in and we're gonna run the analysis here. Okay, so before we run the analysis, let's look at some of the other loading that we have in this model. We have dead load in this model. We have live load, wind load in this model as well. And then we have our dynamic ground motion. This is in the X direction, this is for our time history data. And then we have another dynamic loading in the Z direction that's based on response spectra loading. So we do have two dynamic loadings, one in the X direction, one in the Z direction. One is time history, the other one is response spectrum. Okay, and then we have our load combinations there. So what I'm gonna do now is I'm just gonna run this analysis. And like I said, this model's already set up. So all I did for this model was interchange the time history, seismic time history data. I interchanged what was already there for a different seismic event. And now I'll be able to compare what happens to the structure with information. Okay, so I've run my analysis. You can see the analysis ran very quickly, just 20 seconds. And now we can go into the post-processing mode, okay? Now in the post-processing mode, what you'll notice here, I'm looking at the deflection of the structure. Now this deflection is exaggerated a great deal. And this is, we're looking at actually load case 106 here. Give me a second. Okay. I'm gonna go back to, sorry about that. I may have to, let me see if I can, I might have to exit out of some of these files here. Let me close this one. Yeah, I might have too much stuff open. Sorry about that. And I've already run the analysis here, so I will close this for a second. Close a few other things here. All right, give me a second to let this, to get this started back up. Okay, let's go ahead and, I think I had a few too many programs open at the same time. And maybe I had some conflicting files or something like that. So I just closed everything and I'm just gonna restart it. Now my analysis is already run, so I don't have to rerun my analysis again. What I'm gonna do here is just open that file up and we're gonna take a look at what's happening to our model dynamically, okay? So I'm going right back to that same model. Okay. And now, like I said, we already ran our analysis, so we should be able to go to post-processing mode. And here we can see the displacement of our structure. Now, this is looking at the dead load case. So what we're gonna do is we're gonna look at all of our load cases, and let's look at a combined loading with our dead and our seismic in the X direction. So you can see that these displacements are greatly exaggerated. But what you'll notice about this, and if I view this structure from the front, is you'll notice that the building is actually going in two different directions. So why is that? Well, that is due to the dynamics of the loading that's happening laterally on this structure. So because of the frequency of the ground acceleration, it's actually creating this dynamic effect on our structure. Now, this is not something that we would see if we just look at a static loading on our structure. So for example, if I go back to results here, and if I change it to my wind load instead of my seismic, now you can see here, I'll exaggerate it a little bit more so you can see it is going to be pushing the structure, but it's pushing the whole structure together in that direction. If I consider the dynamic force, let me go to that low case 306 here. So now, again, this is very exaggerated, but you can see that you have the structure actually moving in two directions due to that dynamic loading. And if you go to your displacement summary here, you can see what your maximum displacements are going to be and at what particular node it's going to be. So you can see all that information. Now, another thing that we want to do is actually animate this structure. So if I go here to the animate button and I look at section displacements, here I can just increase these values a little bit. So I'll put in 20 extra frames, and my target frames per second will be 30. I'll click apply. And there you can see essentially what's happening to the structure under this particular load case. So of course you can change to different load cases. I'm sure you're all familiar with that, but you'll be able to see the difference in what's going on here versus for these different load cases. Okay. And you can see that. So that would be giving you more insight. Now, what do you notice about this structure? Well, I have bracings at the first level, second level, third level, and the top level, but I haven't provided bracing for the structure at this level. So that is actually a weak story in my structure. And you can see that the stiffness in this direction, that's where I'm getting the most motion there or most displacement. So I may need to add some bracing in here. So this is a good indicator of where I may be missing bracing and I need to stiffen my structure a little bit. Or maybe I want to add in some dampeners to dampen the effect of the seismic accelerations. So these are some options to consider once you're understanding what's happening to your structure dynamically, and you say, you know what, I need to place either some bracing or some dampeners or have some other devices to control these accelerations. Now, other thing I want to look at here is if I go to layouts and I go to mode shapes. Let's take a look at the mode shapes, okay? Now, why is this important? This is going to be important because we can see at what frequencies our structure's going to have the largest participation. So here you can see at a frequency of 1.3 hertz or cycles per second, we're going to have our greatest frequency or our greatest participation of 75% of our structure. So this is going to be a big one there for us for the X direction. For the Z direction, we actually accelerated the structure in the X direction, but if we had accelerated in the Z direction, we would actually get a higher participation at about 1 cycle per second, right? So you can see based on these modes how all of this plays out on your structure. And if we wanted to then look at the different modes of this structure, we could. So for example, I'm going to go to layouts here, and I'll go to, well, actually, sorry, I'm going to go back to animation. And this time, if I wanted to look at the mode shapes, I'll choose modes here instead of section displacements, click apply. And then we'll just pick the different load cases we want. So let's choose this load case. Now, I want to view the structure. Let me go back here. So I want to actually view the structure from isometric view. So we can, when we're looking at the mode shape, we can see how it's displacing all around, okay, for the different mode shapes. So, and this would be mode 1. So remember, when we looked at the participation factors, we saw that mode 1 was in the Z direction. And then we go to mode 3, that was for the X direction. So you can see the structure moving in the X direction. So if you choose different mode shapes, you'll be able to see which is the controlling direction based on those participation factors, right? And you can see how the structure is going to move. So these will be all the dynamic effects that we want to consider that's happening to our structure. And this is why we would want to do a dynamic analysis. Now, last thing I'll point out here, if I go back to post-processing mode, is if I go to my layouts and go to utilization, in the original model, I didn't have any failed members. Even though I did have time history loading in there, all my members were passing. But now with this new dynamic time history loading, I do have some members that are failing. So now I can evaluate. Now they're not failing by much. They're still up around, you know, almost at just a little bit over capacity, but they are failing. So I could resize those members and then, or make other adjustments to the bracing so I don't have those members failing. So these are some types of things that you'll be able to evaluate and see by accessing the time history data. And again, that website, I'll go back to that website for you here. The website here, if you want to go directly there, it's the strongmotioncenter.org. You can go there and get the latest earthquake data. You can also search for older events if you know the date or you know the location. You can do that. So you get that data, you process it using that converter that I showed you, and then you can, once you've processed it, you just put it into a data file and bring it into your model. Okay, so at this point, I think we've covered the topics that we wanted to cover. Let me just do a quick recap here. Pulling in that historical data, you're going to actually, once you've processed it, you get this file here that's created for you. You're going to go in and copy that text into the EQ data file, and then you can just, by editing the name in the text editor to the new file, you can automatically bring in the new data. And we just went through the whole presentation on all those other topics. So at this point, what I want to do is I want to open it up for questions. You have about 5 or 10 minutes for questions, and then we'll wrap it up for today. So let me see if I can view any questions that we have here. And I'm going to try and do that right now. Okay, let me see. Any questions? Well, while we're waiting on questions, what I'm going to do is I'm going to do a polling question here for the audience. And the polling question. Let me see here. So I pushed that poll out to everyone. So you should be able to respond to that poll right now. Okay. And also, let me see if we have any questions here. If not, there's no questions, then we can just end the session. Okay, I'm not seeing any questions here. Wait, let me just I'm not seeing any questions here, so let's wrap it up. Again, I want to thank everyone for attending here, and just want to mention that we do have these type of trainings that are offered not only in our special interest groups, but you can register online for live instructor-led trainings for STAAD.Pro, dealing with steel and concrete, foundation design, dynamic analysis, and our advanced analysis engine. You may be familiar with our STAAD Advanced Concrete. This is something that is new in STAAD.Pro, so you can take advantage of that for designing your concrete, your structures. Also, we have a lot of great information on our Bentley Structural YouTube channel, so I encourage you to go join in to the Bentley Structural online there. And we want to thank everyone for your attendance. We look forward to seeing you back in April. I believe everyone has my email address, so if you have additional questions or need additional information, please reach out to me. Actually, I'll go back to my email address so you can see it here. This is my email address. If you want a copy of the PowerPoint for this presentation, I can email that to you. So reach out to me through email, and look forward to seeing you back in April. Thanks again. Have a great day.